Well, here's just a little revision video on balancing equations. So a bit of a tricky part of this topic, so I'll go through this slowly and carefully. Okay, right, now balancing equations. What are chemical equations? Chemical equations are a way of showing what happens, exactly what happens in a chemical reaction. And they involve, like we have an example here, they involve the formulae of the elements and compounds involved in the chemical reaction. Okay. Now, the reason why they have to balance is because during any chemical reaction whatsoever, the numbers of atoms of each element has to be the same on the left and on the right. Whatever we start with in terms of atoms, we finish with in terms of atoms. That's one of the most important fundamental ideas in chemistry is that atoms do not change. They just rearrange themselves in any chemical reaction. Okay, so what have we got here? We've got C3H8 plus O2. So C3H8 is a hydrocarbon. Can't remember off the top of my head which one it is, but it's a fuel. It will burn, okay, like all fuels do, in oxygen to produce water and carbon dioxide. Now, on the left, we've got the reactants. On the right, we've got the products. So, but like I said before, the total numbers of atoms of each element before and after has to balance. Right, what have we got at the moment then? Right, we've got on the left the reactants. We've got 3 carbons, 8 hydrogens, 2 oxygens. On the right, we've got 2 hydrogens and we've got 1, 2, 3 oxygens and 1 carbon. Now, as we can see already, none of these elements balance. Right, so let's go with the carbon first. So we've got 3 carbons on the left and 1 on the right. An obvious thing to do first would be to put a 3 there. Now, one of the most important things with balancing equations is we can't just put a 3 there, okay? Because that would be changing the formula for carbon dioxide, and we're not allowed to do that. We cannot change the molecular structure of carbon dioxide. We can't do that. The only thing we can do, if we want 3 carbon dioxide, if we want 3 carbons, we have to have 3 carbon dioxides. It's literally like a recipe. It's literally like baking a cake. Okay, so in this chemical reaction, if you want 1 lot of this, you need to produce 3 lots of this. Okay, right, so the carbons are balanced, but we've also changed the oxygens as well, haven't we? So what have we got oxygen wise? Well, we've got on the right, we've got 1 plus 3 times 2. So 3 times 2 is 6, so we've got 7. Okay, right, let's go with the hydrogens then. Now, 8 on the right, 2 on the, so 8 on the left, 2 on the right. So what we need to do there, okay, let's say 4. Okay, so 4 times 2 is 8. So we've got 8 on the right, 8 on the left. Okay, so hydrogens balanced. Okay, oxygens balanced. So carbons balanced. What about the oxygens? Right, we've now got 4 lots of oxygen here and 3 lots of 2. So what's that equal to? 4 plus 3 times 2. 3 times 2 is 6, plus 4, 10. So we've now got 10 on the right. We've now got 10 oxygens on the right. Okay, we've got 2 on the left. So what do we need to do? Okay, 5 lots of oxygen. 5 lots of O2 would make 10 oxygen atoms, wouldn't it? So we now have carbons, 3 on the left, 3 on the right. Hydrogens, 8 on the left, 8 on the right. And oxygens, 10 on the left, 10 on the right. Okay. Now, admittedly, that was a fairly challenging one. So let's just do a couple of easier ones next. Okay, right. What happens when we burn carbon in oxygen? Very similar to the last one, except we've got carbon. Now, the formula for carbon is C. Formula for oxygen is O2. Gives C O2. Is it balanced? Carbon's on the left, 1, carbon's on the right, 1. Oxygen's on the left, 2, oxygen's on the right, 2. That is balanced. Okay, so we don't have to do anything with that. Easy peasy. Right, what about the combustion of hydrogen gas? Right, slightly different. Hydrogen gas, H2. Oxygen gas, O2. Arrow, reaction taking place. Chemical formula for water is H2O. Right. Hydrogen's on the left, 2. Hydrogen's on the right, 2. Balanced. Oxygen's on the left, 2. Oxygen's on the right, 1. So we need to double up on the water. Like I said, we can't just put a 2 there because that makes a completely different compound. That is actually hydrogen peroxide, which is completely different to water. We can't do that. We can only, if we want 2 oxygens on the right, we've got to have 2 lots of water. Okay? What have we done with 2 hydrogens now? We've now got 4 on the right. So, double up on the hydrogen. We've got 4 on the left. Balanced. Okay? Just count them up. 2 lots of 2. 4. 2 lots of 2. 4. 2 lots of 1. 2. 2. Balanced. Right, what do we got next? Okay, let's have a little look at this one. Balance these symbol equations. Okay, so it's a lot of the time it's just kind of tweaking and chipping away. Okay, right, what have we got here? We've got KNO3 plus KNO2 plus O2. Right, so we've got, let's look at the potassiums and the nitrogens are balanced. Okay, so sometimes it makes it easier if we just write, okay, K equals N equals O equals K equals N equals O equals. This sometimes helps. Right, we've got 1, 1. Okay, nitrogens, we've got 1, 1. They're balanced, but the oxygens, we've got 3 and we've got 4. And that's a bit of a tricky one, this. Okay, we need a factor that has multiples of 3 and 4 in it. Sorry, we need a multiple that has factors of 3 and 4 in it. Okay, can you think of any ideas? Well, let's just try tweaking. So let's double up on that one there. Okay, so that's now we've got 4, we've got 6. Right, what if we double up on there? Okay, now unbalance the oxygens. What have we got on the left? We've got 6 and we've got 6. We need to double up on this, don't we? Okay. Right, now we've got 2 potassiums, 2 potassiums, 2 nitrogens, 2 nitrogens. Right, we've got 6 oxygens on the left. We've got 4 and 4. But what about if we take that down to 1 again? Let's try that. Right. 2 potassiums on the left, 2 on the right. 2 nitrogens on the left, 2 on the right. Now, oxygens, we've got 2 lots of 3. We've now got 6 on the left. And we've got 2 lots of 2 and 2. So 6 on the right. Okay? Balance. So as you can see there, sometimes it's just a little bit of trial and error, a little bit of tweaking here and there, okay, to get the right balance. Okay, lithium and oxygen gives lithium oxide. Right, what do we got? 2 lithiums on the right, 1 on the left, so we've got to double up on that. Okay, 2 oxygens on the left, 1 on the right, so we've got to double up on that. Okay, now lithiums, back to lithiums, 4 on the right, 2 on the left. So, if you have elements on their own, it makes it a lot easier. There you go. Right, balanced? Yes. Right, next one. Fe. So, an obvious thing, we've got 2 ions on the right. Let's make it 2 on the left. Now, oxygens. We've got 3 on the right, 2 on the left. Okay, so I think we've got to go. So again, this is where we've got to think, okay, multiples that have common factors. So how about 3 there? So we've got 6 oxygens. That would make 6 oxygens on the right, wouldn't it? One last tweak of the iron. If we've got 2 lots of 2, we've got 4 on the right, 4 on the left. Make sense? Okay, so like I said, it's just a case of trial and error a lot of the time, just tweaking here, tweaking there until you get it right. Right, Fe's don't balance, so we'll come back to the ions because they're on their own. We can come back to that. Right, oxygens look like they are a problem. We've got 3, 4. We've got 1, so we've got to double up on that, but then we're going to double up on that, aren't we? Okay. Now we need an odd number. We definitely need an odd number of oxygens on the left. Okay, because we've got the 2 there. We can only have we can only have an even number of oxygens on the right. So we need an even number of oxygens on the left. So, okay. What about 3 there? Okay, so we've got 6. And that makes a 3 there, doesn't it? Does that balance? Okay. Right, we've got how many oxygens? We've got 3 there, 3 there. That makes 6. But 3 lots of 2, that makes 6. The carbons are also balanced. That's looking good. Just one last thing to balance the ions. That's going to make 2 there. Okay. So, again, just a little bit of trial and error. That's all it takes. A little bit of tweaking here and tweaking there. Okay. What do we got here? Any more? Burning magnesium and oxygen. Let's try that one. We all know about that. Where we burn magnesium, it's really bright. So magnesium, Mg plus oxygen, O2. Now the formula for magnesium oxide is MgO. This should be fairly straightforward. Got to have 2 lots of that to balance the oxygens and 2 lots of that to balance the magnesium. So some can be quite straightforward. Some can be quite easy. What have we got here? Sodium and water. This could be a tricky one. Let's have a right. Sodium and water. Na plus H2O. Can you remember what is produced? We have, well, firstly, it gives off lots of hydrogen gas and NaOH. Sodium hydroxide. That's what makes it alkaline. Let's have a look. Balance, balance, balance. Okay, oxygens balanced, hydrogens not balanced. Right, so let's double up on that. Okay, but then we need to double up on that. Right, so what have we got now? Hydrogens, we've got 4 on the right, 4 on the left. Okay, because we've got this one and this one, and this one is doubled. So we've got 4 on the left, 4 on the right. Boom. Oxygens, 2 on the left, 2 on the right. Boom. Finally, sodiums, 2 on the right, 1 on the left. Easy peasy. Double that up. So yeah, if you have elements on their own, it's usually best to leave that to last. Have a tweak of the ones of the elements. Have a tweak of the ones that are in compounds. Okay. Any more for any more? I think that's it, isn't it? So there you have it. So there's some examples of balancing equations. But just to recap, the rule, the main rule, or 2 rules are, okay, the 2 rules are the numbers of atoms of each element has to be the same on the left as on the right. That's rule number 1. And rule number 2 is you can only have multiples of the whole thing, the whole molecule. Even hydrogen, we can't make that H3 because that doesn't exist. Hydrogen's always going around in pairs, H2. The only thing you can do is double up, triple up, or quadruple up your compounds and elements. Okay? Well, I hope that made a bit more sense. Any questions, please get in touch. Thank you.